our radian measures that we're going to be using in order to come up with principal angles and related acute angles. So remember, our 30 degrees, that's going to be equivalent to pi over 6. 60 degrees is going to be equivalent to pi over 3. And 45 degrees is equivalent to pi over 4. Okay, so now we're going to figure out first how to identify the principal angles first. So if you were given a question, cos 7 pi over 6 is equal to negative root 3 over 2. Negative root 3 over 2. Well, first of all, it makes sense to identify. Now, what angle are we talking about? What involves root 3 and root 2? Which special triangle? So I know that 7 pi over 6 is 210 degrees. So right away, because between 180 and 270, I'm going to have that angle, 210 degrees. But how do I identify what this angle is? Because I'm going to draw it up like that. And it makes sense that is cos negative in this quadrant? Yes, right? Only tan is positive in this quadrant. So that makes sense. But what is the degree measure? Well, very simple. Now, if I know this is 210 degrees, I'm going to figure out 210 degrees minus 180 degrees. What is that answer going to be? 210 minus 80 degrees is 30 degrees, right? So this is the 30-degree triangle. So I'm specifically looking at this triangle. I know my hypotenuse is going to be 2 for the 30-degree triangle. And cos is adjacent. So this is going to be root 3, negative root 3, which leaves this as 1. Does everyone agree with that? Okay, now, so right now we're only focusing on the terminal angle, but you're right, that terminal arm. Now, we could have a related angle, but here we're just showing the value of cos 7 pi over 6. We're not looking for related angles yet. We're going to get to that question. If we had something, and so this is how you would demonstrate or prove that cos 7 pi over 6 is equal to negative root 3 over 2, because cos of 7 pi over 6 is equivalent to negative my x, which is, or just and my x over my radius, and my x is negative root 3, my radius is positive 2. So I'm just proving that. Okay, let's do these ones. A point 1, negative 4 lies on the terminal arm. Determine the principal angle. State the 3 primary trig ratios for theta given the point negative 3, negative 4 lies on its terminal arm. I'm talking about point positive 1, negative 4. Without having to figure out the radius, I can use the definition of tan. Tan of theta is equal to y over x. That means that tan of theta is equal to my y is negative 4, my x is positive 1. So theta is going to be equal to the tan inverse of negative 4. But if I want to solve for my related angle, so say the related angle is alpha. Okay, so I don't want to solve for this angle. I want to solve for the related angle. For part B, we're going to do the same thing, -3, -4, and you want to solve for your primary trig ratios. So the first thing we have to do is figure out our radius. Your radius is equal to the square root of -3 squared plus -4 squared. When you calculate that, that is going to give you a value of 5. So sine theta is equal to y over r, which is equal to -4 over 5. Cos theta is going to be equal to x over r, which is -3 over 5. And tan theta is equal to -4 over -3, which is +4 over 3, opposite over adjacent. In the next part of your unit, we'll also be going to cosecant, secant, cotangent, which you learned a little bit last year, but you're just flipping your ratios, y over y, r over y, r over x, and x over y. Now, what Kane was talking about, more examples of related angles. Let's do that next. So, say you are given a value, state an equivalent expression with the same related acute angle. So you're given cos 4 pi over 3, and you have to find the related acute triangle. So on your calculators, punch 4 times 180 divided by 3, and you should get a measure of 240 degrees. Now, if we're actually drawing that out, 240 degrees, we know that we're going to be able to draw related angles in different quadrants. Now, what is 240 degrees equivalent to? 240 degrees. So if we take 240 and subtract 180, you get 60 degrees, right? 60 degrees is the same thing as pi over 3. So we would have pi over 3 this way, and it would be negative. A pi over 3 this way, and because cosine is negative in these two quadrants, pi over 3 this way, and the pi over 3 this way. So if we're looking for negative pi over 3, cos 4 pi over 3, 240 degrees gives us a negative quadrant. The only other quadrant where it's also negative would be this quadrant as well. So you're going to focus on these two quadrants, right? So cos 4 pi over 3 is going to also be equivalent to 240 degrees if we take 180 degrees and we subtract 60 degrees. What are we going to be left with? 180 minus 60 degrees. 120 degrees. Right? Which is equivalent to, see if this is right. Well, that's going to be equivalent to cos 2 pi over 3. And in your unit guide, they might ask you if we wanted to have, well, we're going to stop there. This is the only angle it would be equivalent to if we're just talking from 0 to 2 pi. If they give you the range for your range is 3 pi, you would add another 360 degrees to 120 degrees to get another related angle, or 360 degrees to 240 degrees to get another related angle. Does that kind of make sense to you guys?